Now see how can we do for opamp as a differentiator. Just draw the opamp. Okay, again the feedback is connected with the negative terminal, that is the resistance over there, so that is denoted by RF. There is a capacitor also connected with the input terminal. As you can see that it is completely opposite from the integrator. In the integrator, capacitor is here, resistor is here, but in this case in differentiator, capacitor is here connected in the input. Okay, we'll provide the input voltage over here, and another terminal would be grounded. For the positive one, terminal is grounded. This is voltage V in, this is C, and this is R, and we'll get it as a output voltage denoted by V naught, right? So I can mark it here that in this IF current is flowing and in this IC current is flowing. Again, can I write down by applying KCL, that is IC is equal to IF, right? Because no current is moving over the op-amp due to the concept of virtual ground. So IC, as you know, IC is how much? C dVc by dt, right? Now IF is moving from 0 to V0 or V0 to 0? IF is moving from 0 to V0 or V0 to 0? Tell me. It is moving from 0 to V0. So that would be 0 minus V0 divided by RF, right? So similarly, what we want to calculate here, the value for V0. How can we get the value of V0? If I'll write down, can I write down like minus V0 by RF is equal to C dVc by dt, right? For VC, what we can write down? For VC, we can write it down as an input voltage only because it is moving from V in to 0. So that would be V in minus 0. So I'm writing down VC is equal to V in only. So RF can goes to this side, so it would be RF into C d by dt of V in is equal to minus of V0, right? So if I'll calculate the V0, that V0 is equal to minus RFC d by dt of V in. D by dt means we are having the differentiation. So we are having the final output, that is output voltage is equal to the resistance multiplied by the capacitance into d by dt of V in. So this is our final conclusion for the op-amp as a differentiator.